Welcome back. In the previous tutorial we looked at how to set up a unit that uses a different skeletal mesh from the default humanoid rig. And in this tutorial we will be looking at how to set up a unit that doesn't use a skeletal mesh at all, but rather uses a static mesh as a way to display it. Now, what do we want to base this new unit on in this case? I mean, it might be tempting now to just use the BP unit. By the way, I've never shown how this looks in game, but it still works. So it does damage immediately. So it works in just the same way, just that it has no animations, and then we die immediately when we are reduced to 0 health, but you can't see it or anything. We should delete this guy. So of course the simplest way to do this all would just be to take this unit and add a static mesh, and there you go. But we probably want to have a health bar or something like that if you're not setting up your own kind of health bar variant. So let's even if we're not using a skeletal mesh, let's take this BP unit anim as our basis and then just delete all the stuff that we're not using. So I will call this BP unit static. Okay, so we have a lot of stuff here we don't need. We can delete then the weapon, and we want to delete the skeletal mesh, but we have the health bar and the exhausted icon tied to it. I'll just delete the exhausted icon too, so we don't need to look into that in this tutorial. But we want to have a static mesh instead of a skeletal mesh. I'll just call it static mesh, that's fine for this tutorial's purposes, and we will use a very simple static mesh. I'll just use the default engine cube mesh. If you can't see this, you can show engine content here in the view options and you should be able to find it. And there's a big cube. And so let's just attach the health bar to it and attach it to the grid anchor. If it's not attached to the grid anchor, yeah, I can show how that looks. Oops. Let's close all of these that we used in the last tutorial, by the way. Okay, bad blueprint. Bad. So there's something wrong here I need to clear up before I can demonstrate this stuff. Yeah, let's just get the stuff out of the way that references. Let's see, so animate action, which is, yeah, toggling the exhausted icon, which I have deleted. This is also then for the exhausted icon. Let's see, exhausted icon. And let's see, we don't need to set up a reference to the animation blueprint since we have no animation blueprint. And since we're now just calling the parent event, we can safely delete this too. For the move timeline, do we want to have a move animation? Maybe, but we don't want to animate the animation blueprint, certainly. Same thing here, we don't want during animated unit to animate the ability, so we can delete this. But we want to set the visibility of the health bar to not visible when it dies, so this we can keep. And for this we want to modify the health bar when we are hurt, so this we can also keep. Great, okay, now it should compile. And since we have not attached the static mesh to the grid anchor, if we now draw this into, you will see that it does not snap to the grid. So this is mainly a problem as you are placing out units on the map. It shouldn't affect the actual game, but if we do this, it will look nicer. Now this is a really big unit, so let's make this static mesh a bit smaller, 0.5. Let's take a look at it. Oops. And I think it is, yeah, it should be clipping through the floor since the center is at 0. So we put it at a height of 50 and it should be here on the floor. That's a better size for our unit. And one thing that is very important whenever you make a new unit, and I see this error being done again and again for people in the support thread, and that's understandable. So let's clarify it in this tutorial. If you add a static mesh, or like really anytime you add a static mesh using this toolkit, you should be mindful of its collision settings, because the toolkit uses different sorts of collision traces for some of the gameplay code. For instance, you have the let's look at the channels here. So for the collision presets, if I set this to custom, you have these different standard traces, but you also have the ones that come with the toolkit. So you have path trace, and path trace, this is the trace channel that is used to check at the start of the game what tiles can be walked on. So this entire floor here blocks path trace, so that the grid manager knows that you can move on top of these tiles. And if you add like a new platform or anything that you want to be able to move on top of, it needs to block path trace. But if you have a new unit here that uses a static mesh or a skeletal mesh that blocks path trace, then at the start of the game the grid manager will run traces down to the center of each tile, and it will do so, and it will hit the top of your unit, or your unit here if this guy blocks a path trace, and it will think that you can move on top of them. And for the rest of the game, when you move past this space here, the unit will then fly into the air and go back down again. So we certainly don't want to have this active. And for range trace, this is what checks line of sight. So whenever range trace is blocked, when a ranged unit or any unit tries to figure out what units or what tiles it can attack, it runs then line traces to every tile to see if it is blocked by anything, and then it checks the range trace channel. If this guy here is blocking the range trace with his mesh, he will try to trace and he will hit himself, so he will not be able to find any tiles at all. So we don't want to block range trace. Cover trace, this should be set to false by default. This is used in the advanced example for the cover system. So if this is true, he actually creates cover, but not whenever he moves. This is also just checked at the setup of the game. So we want this to be false certainly. And wall trace is used with the procedural grid options for tracing for walls, where the grid can procedurally check for different walls and then remove walkability between any tiles that are blocked. So naturally we don't want this to be blocked either. In fact, we don't need to set up a custom thing for this, because we should not want this unit to block anything at all, really. I mean, you might want to if you also have other kinds of things in your game that are interacting with your unit. If you have like stuff that can be thrown on it and bounced off the mesh and so on, then you can set up a custom, but make sure that all of these are at least false. In this case, we can just set it no collision, and we can't step up on him, and we don't want to generate overlap events. If you have no reason for having any of these actives, then you can just turn them off, and that should be better for performance as well. Okay, that was a long digression. Let's get back to this unit. So let's see if he is working as he is now. I just want to increase his initiative so that he is always starting, since this guy is at 0. Let's see, we can move and we cannot attack. So what is wrong here? Let's see. So the thing is, yeah, the animate unit, we need to then add a call to the parent function. Oops, because this is just, yeah, I mean, we can just delete this and it will call to the parent function by default. So if we now attack, yeah, we instantly do damage, and when we are hit, we take damage. And let's see, let's have this guy kill us. Yeah, and then we just stay there. So one thing we at least want to do is to hide this guy when he's killed. So we have the animate death here, and we can set the visibility of the health bar, but we can set the the visibility of the entire guy, really. But maybe we want to be a bit more fancy than that and have some cool animation happen when he is killed. Now, of course, we're not using an animation blueprint, so we'll have to set up our animation some other way, and we can do that directly in the event graph. Now for the animate death stuff, this is just for setting up the health bar. For animating the unit itself, we can use the animate unit event, which we do not have a reference for here. Let's see, I might have deleted a bit too much. BP unit anim, so we have the animate unit. This is the one that usually interfaces with the animate ability blueprint, but we want to set up our own. Let's see, custom one instead. Oops, that did not work. But if we do, there we are. Okay, so let's do this manually. So we have an action, we can break this action, so we have access to all of the variables stored within it. And one of them is the action name, so the one that we currently want to animate. This is again a thing I explain more in my my action system tutorial. Okay, so we need some pins. So what specific pins do we need? We can actually check like some of that stuff we have here. So we have the move and death and hurt, select, update ability box, a few different ones. For this unit, I just want to overwrite the hurt and the death, and when it attacks, which should be handled by default. Okay, so we add a couple of cases. We already have some cases. So hurt and death, and we'll use default to handle attacks. Okay, so let's start with hurt. So what do we want to happen when this box is hurt? So how can we illustrate a box being hurt? Maybe it can like shrink slightly as it is being hit or something like that. So for this we can use a timeline. So let's create a new timeline. So timelines, they're like, kind of like self-contained tick events, really. So if we play this one from start, it's going to play through whatever you have decided here in the timeline, and when the timeline ends, which we also will define, then it is finished, and we will then call for our action to finished. So let's change the timeline here. Here we can add a few different tracks. So what we want to do here is to resize the unit slightly as it is being hit, to like shrink a bit and then to expand again. So we can just uniformly change its scale. So since we're doing this uniformly, we just need a single float value for this. So let's create a new track, and we can call this hurt shrink. That works, and let's shift click, and then we can add some new values. This should happen fairly quickly, I think. So let's have it happen over 0.3 seconds or something like that. So we start at time 0, and then we go to time 0.3, and let's have a point in between these so we have a bit more control, 0.15. And for this, since I want to shrink it, maybe I want to have it shrink to be half size. We can just directly input the values here if we want to, and have these be at 1. So let's see how this looks. Oops. Yeah, and we should have a time that is not greater than the time of our animation, so that we can call the finished event when the timeline is over. So now it is shrinking, and then it grows larger again. Though this is kind of a very sort of choppy, jagged, linear motion, and it often looks better and more organic if we change this a bit. So for this, I think we can use the auto. Yeah, that seems to work great. So now we have this float track that changes along with this timeline. and we can use this to change the size of our actor. So let's set actor scale 3D, and during update we input this value into its scale, and then it should shrink and then grow larger again. And then we want to end the action after we are done, so we call the end action function. I can copy this, or to show how to do this without copying. So telling the action system to end this action. So now we should be able to visualize this cube being hurt. Let's see if it works. Just move over here, end our action, and there we are. Great, and it keeps going. Now for death, I think we can do something similar, but maybe we'll make it a bit more fancy. So let's just copy over the timeline, make a new one, and we'll call this TL death. And for this timeline, let's say we want to also shrink the unit until it shrinks into nothingness, but at the same time we want it to rotate quicker and quicker. So then we need a couple of different flow tracks. So we have this the hurt shrink track here. We can just delete this and create a new one. So let's call this death shrink. It's a good name for a band. And let's say we want this to take like a second, and we want it to shrink, and then we don't need like a center because it's always going in one direction. I don't think I need more control than that. So let's put the length of all of this at 1. We put the second time point here at time 1 with a value of 0 where it is shrunken to nothing, and we start it at time 0 with a value of 1. Let's zoom to fit so we can see this, and we also want some sort of organic, I think, curve for this, but we don't want it to shrink slowly, then quickly, and then slowly again. I want it to go gradually faster and faster as it's shrinking. So let's select both of these points by shift clicking, and then having a user created curve. Then we can change these tangents. And yeah, so now it is shrinking. We can just start with this and come back to the rotation afterwards. During update, we will set the scale again of this actor, and we will set it based on death shrink. And again, just let's end the action, and this should work too. Let's put the health so we can survive a couple of hits, but just 2. Then just end our action. And again, and we shrink. Great. So now let's add more to our track, or another track rather, to our timeline so that we can have that for our rotation. So let's call it death spin. And we'll also start this at 0 and end it at 1. There we are. And we start by spinning, I guess not at all, and we slowly, or quite quickly actually, increase the speed of our spinning. So we end at time with a value of, so we can use this value to say like how much we change the yaw rotation of this unit every tick. So at the end we can change it quite quickly. Let's say like 20 degrees per tick, which is pretty quick. Let's see if that works. And then I also want this to be, yeah, actually the same sort of gradual slope that we had for this this other, for the shrinking. Oh, they're both changing at the same time, are they? Yeah. So we can do the same thing as we did and do a user-defined slope here. So we start, let's see, start fairly slow and then we spin quicker and quicker and quicker. That looks good. Now we have a different output here, so we can use this to then set actor rotation. We split this so we can just change the yaw. So then we can get the current location of this actor get the yaw, just input the roll and pitch. We'll just keep this consistent, take its current yaw, add this death spin variable, and it should be spinning. Let's see. So we're hit, and then great. Finally, let's add an attack animation. So if we go back to BP unit static, we get this from the default, and we will also use a timeline for this. I'll just create a new one. Oops. And TL attack. Play this from the start. Okay, so how do we want to attack? So here we can maybe then jump forward a bit to hit and then jump back. Come to think of it, then that means that this hurt wobble might actually serve as a good basis. Let's use that. Okay, so we jump forward and then jump back again. Let's see. We maybe want to have this go the opposite way then. So we're jumping forward to 0.5 to like right between the tile that we're attacking from and the tile that we are attacking. So this should be then a value of 0, representing the center of our own tile. And it can have the same speed, that's fine. Okay, so the thing is, we can't just simply manipulate the location of the current actor here without any reference to the other actor, because we need to know what other unit we are moving towards. Thankfully, we can get that from the action here. So again, this is something I described in the action system, but we can look very quickly at where this value is sent. In this case, since we are using for these units, as you can see, let's see, here they are using the ability move attack. This is the ability that all units use by default. So we can check in this ability to see how attacking is defined. So we can see an animate action for this ability that during attack an action is queued, and in this action, which is called ranged, but since we have no definition of ranged within this unit here, it will be using default instead. And it is also inputting the location of the target unit as a vector. So we have access to the location of the target through this action. And you can also see that it does not have instant deactivate set to true, which is why we need to call the end action manually. If this is set to true, then it will instantly deactivate the moment the action begins and before it has even we've seen it resolved. But yeah, so we do have access to the location of the enemy unit, and we can get it through here. So let's get then index 0 from this array of vectors, and we have that here. So now we want to set the location of the current actor. So we can then during update set actor location, and where do we set it? We want to set it then to be driven by this timeline to go towards whatever we are attacking. So we want to interpolate then between our location and the location of the enemy. So let's do a vector interpolation between this and our starting location. So we need to get our starting location, so we can then get actor, get actor location. But we can't get the actor location here during the update, because if we do, every time we check it, it will have changed. And then we will quickly just spin over outside the map. So we need to set this up before this timeline begins as a variable, so that we have something constant that doesn't change to refer to as our starting point. We could promote this as to a variable, but as we're just using it here, this seems unnecessary. So I have added a handy macro to the toolkit, which is make local variable. So now if you use the make local variable macro, the output you get here will be whatever you used when you initially set it. So now we can use this value here, and then we can interpolate between these two. Let's see, interp. Maybe it's in linear interpolation, lerp vector, yeah. So our starting location, and that's A, and then the location of the enemy we're attacking is B, and then we're driving this by this, yeah, it's still called hurt shrink. Let's change the name to then attack thrust, maybe. And we can use this to set the actor location. And when finishing, again, we need to make sure to call end action. I might change this combination to a macro in the future, so don't be surprised if it looks a bit different when you look at the toolkit in a future update. Okay, let's see if this works. So we're moving, and we're attacking, and we're not hitting. Of course we're not, because if you recall from a previous tutorial, we had a hit event that was called during the animation, during the attack animation, for when the attack hit, and we need to do this in some other way here. So if we again look at the ability, we actually looked at the attack ability, not the attack move ability. I'm seeing here the move attack ability. Here we have the animate actions, here we have the attack. We can see here that this attack code is waiting for the attack hit here to keep going after, and then to hurt the enemy unit. And this is done by, before this action is being called, it is binding an event to on attack hit, which is an event dispatcher which is contained within BP unit. So we need to make sure to call this event dispatcher when we hit the enemy. And we can do this, let's see here, through our timeline. Actually, we can add an event that happens right here when we're at the top of our animation, which works much the same way as adding a notify in an animation blueprint. So we can here add an event track, and then we can add an event which then happens, shift click again here at 0.15, and the value of this doesn't really matter in this case. So let's call this then hit event, and if we go back here, we have an event, and for this event we can call our event dispatcher. So the event dispatcher is held in BP unit. You can see it down here as on action hit. So we have access to this in BP unit static, as it is a child blueprint of BP unit. So on action, call on action hit there, and let's see now. There we are. Now we're hitting, and he can hit us. The only thing is that this cube isn't rotating when it's attacking, so we're just attacking in whatever direction we want. So let's add that as a last thing. So before we do any of this other stuff, or before we do the timeline and the animation, at least we can rotate to face the unit that we're attacking. So let's set actor rotation. There we are. From start, we just want to change the yaw really. So get actor. Oh yeah, we have the location already here. So oh yeah, wait. Get actor. Whoops. Rotation. Roll and pitch will keep the same. And for the yaw, we can get the look at location. Rotation, I mean, find look at rotation. So the rotation that would be if this location is looking at this location. So our location versus the location of the enemy. And we can get the yaw from this. This doesn't look too pretty, but yeah, this is the last part of the tutorial. Let's just ignore that. And that should, yeah, that looks okay, I think. Let's see. So now if we're moving, we should rotate to face, we do, and then we attack. And attack again. And there's our spinning death animation. Great. So that will be it for this series on how to animate units in the toolkit and how to change their skeletal meshes, and also using other meshes. So I hope you learned a lot about how to use the toolkit, and maybe also some more about how to use Unreal Engine in general. So with that, that concludes this series, and have fun making games.